This is problem 13 from chapter 13. Block A has a weight of 8 pounds and block B has a weight of 6 pounds. They rest on a surface for which the coefficient of kinetic friction is 0.2. If the spring has a stiffness of 20 pounds per foot and it is compressed 0.2 feet, determine the acceleration of each block just after they are released. So you may want to add the equation for the force of the spring to your equation sheet. And that says the force of the spring is equal to the spring constant K times S, where S is equal to L minus L naught, where L naught is the uncompressed length of the spring and L is the length of the spring at the moment that you're calculating the force. If the spring is compressed, L is going to be less than L naught, so in this case, S would be negative. However, we aren't really interested in the sign, we're just interested in the magnitude of the force because we're going to figure out what direction the force is in when we do the free body diagram. So we can just say the magnitude for the force of the spring is equal to K times the absolute value of S. So I'm going to do a free body diagram for A and a free body diagram for B. And I have a normal force acting on A. I have a normal force acting on B. I have the weight for A, which is 8 pounds. I have the weight for B, which is 6 pounds. I have a coefficient of kinetic friction, which tells me that I have a force of kinetic friction. When I squeeze the two, well, let's look at the force of the spring first. So when I squeeze the two blocks together, the spring is going to be acting on block A in this direction. So this is the force of the spring on block A. This is the force of the spring on block B. But these forces have the same magnitude in the opposite direction, so let's just call it F sub S. And then if that force is acting to the left on block A, that would move the block to the left, and so the force of kinetic friction is going to be in the opposite direction. So we have the force of kinetic friction on block A. Same thing for part B. This would be the force of kinetic friction on block B. Let's go ahead and look in the vertical direction. So we have the sum of the forces in the y direction is equal to 0 because the block's not moving in the y direction. The acceleration in the y direction is equal to 0. So for block A, that gives us the normal force is equal to 8. For block B, we have the normal force is equal to 6. So in this case, the normal force is equal to the weight of the object because there are only two forces acting in the vertical direction, and none of the other forces have a component acting in the y direction. So then let's calculate the force of kinetic friction. The coefficient of kinetic friction is the same for both blocks. So we have 0.2 times 8, which is 1.6 pounds for the force of kinetic friction. And for block B, I have 0.2 times 6, which is 1.2 pounds. Well, while we're at it, let's also calculate the force of the spring. So that's equal to the spring constant of 20 pounds per foot times 0.2 feet, which will give me the force of the spring in pounds, and that is 4 pounds. So now that I've done that, I can look at the sum of the forces in the x direction on block A. That's the mass of block A times the acceleration. In the x direction on block A, I have the force of the spring acting to the left and the kinetic frictional force acting to the right. The force of kinetic friction is 1.6, so that's 1.6 minus 4 is equal to the mass of the block, which is 8 pounds, divided by 32.2 feet per second squared. and that gives me an acceleration of 1.6 minus 4 times 32.2 divided by 8. That is negative 9.68 feet per second squared, and that's for block A. And the negative sign makes sense because the acceleration is going to be to the left. For block B, I have the force of the spring, which is 4, minus the force of kinetic friction, which is 1.2, is equal to the mass of block B, which is 6 pounds, divided by 32.2 feet per second squared, times the acceleration of block B. Therefore, the acceleration of block B is equal to 4 minus 1.2 times 32.2 divided by 6, which is 15.1, and that's positive because the acceleration is acting to the right, and that's feet per second squared. And that concludes problem 13.